board. Okay, first question. Here's a function here, weird function, weird piecewise function. And they're asking me the limit as x approaches -2 of f. Okay, so I'm going to point to someone, but please answer me. Okay. So let's say Monique, you here? Okay. Irina?
Yes, hi. So when you approach -2, well, we have to look at both sides. So from the left and from the right.
Perfect.
So from the left, when we approach 2, it's going to be 3.
What? So when you approach, no,
No, sorry, I'm looking at the wrong side. Sorry.
Okay, perfect.
So when you approach from the left, it's 0.
0, and when I approach from the right,
it's 0 as well.
0 as well. Okay. So the closer the x gets to -2, okay, the closer my function gets to this open dot. And so even though the function is not equal to 0 at -2, it still approaches 0. Very good. So the answer here is 0. Perfect. Okay, when x approaches 0, so let's try someone. Janisha, you want to try?
Yeah.
Okay, good. Go for it.
Does not exist?
Okay, so no, one second. I ask the questions, you give me answers.
Okay, I'll go ahead.
Don't answer me with a question. Answer me with something that you're confident, okay, so that I know that you understand. Okay. So
I think somebody's in the waiting room.
I just let him in.
I think there's someone else.
Thanks. Oh, there's someone else? I don't see. It doesn't show in my screen.
No. Okay.
Okay. Anyways, they should put a knock that I see someone's here. Okay. So sorry, Janisha, go for it. What? So you tell me it does not exist?
Yeah.
Let's see. Okay, tell me why it doesn't exist.
Because it keeps on going to infinity.
Okay. So if x is approaching 0 from the right side, right? You're walking towards the 0. Well, my function is going to plus infinity. You're right. And if I'm approaching from the left side, so I'm approaching again 0 from the left side, my function is also going to infinity. So the limit exists. It's not does not exist. It's infinity.
Oh, okay, got it. Sorry.
Okay. You don't need to apologize. Okay. Next, f prime of 4. Liam.
Hello, can you hear me?
Yeah. Okay. F prime of 4.
Does not exist.
Very good. Okay. So f prime. Okay. So we're at 4. X is 4. F prime is, it's the slope of the tangent here. Okay. So the slope, and as you see, the function here has a sort of a pointy part. So definitely there is no tangent line on a pointy part. So the derivative or the slope does not exist.
Look, does it mean that the graph of absolute value is not differentiable?
Absolutely. You're right.
Because it looks like a absolute value graph.
Yeah, exactly. Yeah, perfect. You're right. 100%.
Okay,
it is differentiable everywhere besides from 4 here. Yeah, you're right.
Okay. Thanks.
Okay. Now limit as x approaches infinity as of f of x. So Monique, you here? Okay. I'm gonna get her. Okay, so let's go. Rebecca.
Hi.
Go for it.
Okay. To infinity.
Huh?
I'm not sure.
Okay, so it's okay. Okay, if it's wrong, don't worry.
I'm gonna say infinity. I don't think it's right.
Okay, it's not right.
Yeah.
Why did you say infinity?
Because I followed the graph going towards positive infinity.
Perfect. So that's the x. Good.
Yeah, that's the x.
The x is going to infinity. What does the y get close to?
The y gets close to, it looks like 0. Well, yeah.
It's 0.
Okay.
It seems like the further you go in infinity, the closer the graph will be to 0.
Okay.
Okay, this is an asymptote. Okay, it's an asymptote just like you did in high school. So this is 0. Okay, next one, E. Benjamin, want to try?
For E, yeah.
Go
Give me
for
a
it.
sec. Would it be 1?
Okay, why 1? How did you get 1? So E is this little formula here.
Well, that's the derivative, the definition of a derivative, no?
Perfect, yeah, perfect. So it's the derivative at 6.
Yeah.
Derivative at, okay, good. So we're looking for at 6 right here. Okay, so you told me 1 because it's this, right? It's 1?
Yeah.
Okay, so what you gave me is f of 6. I don't want f of 6, I want the slope at 6.
Ah, okay.
Okay, that's the slope. So what is the slope of this? So that's weird.
Negative
What?
something. It's negative something.
Oh, okay, it's -1. Okay.
Negative 1.
Yeah, -1. Okay, I don't like it too much because there's no grid, so you can't really identify points. But then again, you know, this point we have, so that's 4, 3, and 7, 0. So you can find the slope here.
Yeah.
Okay, so 4, 3, and 7, 0. The slope will be -1.
All right.
Okay, good. You guys good with this? You want me to repeat that?
Yeah, could you just repeat why it's not 1?
Oh, because 1, this 1 here, okay, 1 is f of 6. F of 6 is 1. The image of 6 by this function f is 1, right? The source, the image. That's 1. But they're not asking for f of 6 here. They're asking for f of 6 plus h minus f of 6 over h, which is the slope at 6. The slope of the tangent, which actually is a straight line, at 6. Do you understand?
Yeah, thank you.
So the slope here is between 0.70 and here, which is 0.43. y2 minus y1 over x2 minus x1. We know how to find the slope, and so it's going to be -1. Okay. Any questions? F. So let's try it. Zainab, want to try?
I really have no idea.
Oh, even better. Even better. That's what I'm looking for. I'm looking for everybody who doesn't understand so that they understand now. Okay, so you're going to make an effort and you're going to understand.
Okay.
Okay, and if you get it wrong, there's no problem. Okay, so let's go. Limit x approaches 2 f of x minus 2 squared. No clue?
Is it
Again, you're asking the question. Is it? No, it is. You're not guessing. Tell me what it is.
infinity?
Okay, why is it infinity? So we're at 2, x is approaching 2, right?
Yeah.
X is approaching 2, so that means x is 2. I'm going here. So if x is getting close to 2, well, it doesn't seem to work. Because if I'm approaching from 2 from the right side, well, it's getting close to 1. But if I'm approaching 2 from the left side, well, the function is getting close to 3.
So it doesn't exist?
I don't know. Okay, so let's do it. This one is interesting. Okay, so let's see from the left. So limit as x approaches 2 from the left side. Can you see with this pen, or is it too thick?
No, I can see it.
Okay. Okay, so of f of x minus 2 squared, well, this will be, so if I'm approaching 2 from the left side, my function is getting close to 3. Okay, so this will be 3 minus 2 squared, and that's 1. You good?
Yes.
Okay, and now let's do it from the right side. So the limit as x approaches 2 from the right side of f of x minus 2 squared. So if I'm approaching 2 from the right, my function is getting close to 1. So this will be 1 minus 2 squared. Oh, I get negative 1 squared. Everybody knows that this is 1. So the limit from the left and from the right are the same, and therefore the limit exists. F of x minus 2 squared, the limit will be 1, because left and right are the same.
Or I thought there were
Yes.
absolute values.
What?
I
Oh,
know there were brackets.
Oh, no, they're not. Well, it doesn't change anything, really. Even if it's absolute value, it doesn't change. You would get the same answer.
What if it was,
Why?
wouldn't it be minus 1 if x approaches 2 plus?
So if x approaches 2 plus, yes, you'll get 1 minus 2. What?
Minus 1. Then we put minus 1 outside of the parentheses
Why,
and it's going to be
why outside? Why you took it outside? I don't understand.
okay.
Okay, if this was absolute value, this would be 1. Perfect. It's okay. And 1 power 2 still 1. It works.
Okay.
Okay, good. That was the first question. Okay, so this is an exam question. Okay, I took it from an exam. Let's do another one. Okay, let's go here. Monique. Okay. So I want you to do this one. Could you put your microphone on? Monique, you here? There's a lot of noise in my house. Okay, all right. Okay, so let's do somebody else. Carlo?
Yes, hi.
Okay, let's go. What's f of 2?
Minus 4.
Very good. What it seems like a question what you told me. Okay, so minus. Okay, f of 2. So when x is 2, the function is where the dot is. So it's -4. Perfect. Okay, I'm going because this is easy. But if you have a question, let me know. Limit x approaches. Yeah, question.
No, there's nothing. I said just
Perfect. Limit x approaches -3 of f of x. Kayla.
Positive infinity.
X approaches -3. Perfect. Negative. Why negative?
No, I said positive.
Oh, you said positive. Sorry. I thought positive infinity. Okay. So if I'm approaching -3 from the left or from the right, I get to positive infinity. Perfect. X approaches -1. Avi.
2.
Yep. Perfect. Okay. So if I'm approaching -1, this is -1 left and right. I'm always approaching this open dot, which is at level 2. Excellent. X approaches 2 from the left. Tiffany?
-1.
2 from the left. 2 from, very good. So we're getting the hang of this, I see. X approaches 2. Toby?
Does not exist.
Does not exist. Perfect. Okay, left and right. Right, left, not approaching the same place. Perfect. And negative infinity. Vanisha?
2.
Yep. Okay, question? Second one was much more easy for you guys, seems. Let's go, 2 more. Alexandra? Alexandra, sorry, I have two of them. So Ali Ferris.
It would be 0.
So limit x approaches 1 f of x. So what did you say?
It would be 0.
I don't know. Are you sure? You're not? What is it? 0? It's not 0.
It's 0.
Okay, 0. Perfect. Okay. Limit x approaches 10 of f of x. Let me see, Arthur.
Minus infinity.
It seemed like a question also. Okay. Minus infinity is good. Okay. C. C1.
Yeah.
Limit h approaches 0, f of 2 plus h minus f of 2 over h. What is it?
Right, 4 over 3.
What is it?
Oh, sorry, 2.
2 is good. Perfect. Do you understand this one? Everybody?
Yeah, you just the slope.
Yeah, it's just a slope, but everybody is clear with this? Okay, so this is basically, it's the slope at 2, or if you prefer, we could write like this. This is equal to f prime of 2. Okay, the slope at 2, which is like you said, perfect. It's the slope here, which is between 0.0 minus 2, and this is 0.24. 3.4, sorry. Yeah, the slope is 2. Perfect.
Could we
Okay.
also take 0.10?
Yeah, you can. You can. Even though it's empty, but it's straight line. You're right. 3, 4. Perfect. Okay. Limit x approaches infinity of f of 1 over x. Okay. So I need to see Natalia.
I'm not sure.
It's okay. X approaches infinity, f of 1 over x.
Will be 0 because 1 over x.
So 1 over
0.
x is 0, yes. And f of 0 is?
So f of 0, oh, okay. Minus 2.
Fine. Okay. Okay. Limit x approaches infinity, Michael?
Yeah. Hold on.
X approaches infinity.
It would be 1, -1.
-1, perfect. Okay, and f prime of 5, Krish?
4.
F prime of 5. Yeah, how did you get 4? I think you told me, no, you told me f of 5, right? F of 5
Yeah.
or f prime of 5 is what?
Oh, f prime. Okay, I didn't see that.
Prime, yeah.
F prime of 4. Wait, hold on.
Take your time. F prime of 5. Yeah, it's here.
Would it be?
No, I don't accept questions. Tell me, assume, if it's wrong, it's wrong.
I don't know. Is it 0 or does not exist?
What is it? 0 or does not exist? You tell me.
0. We'll go with 0.
Wrong guess. It does not exist because at 5, the function is not continuous. And since it's not continuous, it's not differentiable. There's no slope here. Okay? There's no slope at 5. Good. The function is not even, not only is it not smooth, there's even a jump there. There's no, you can't find a tangent here. Okay, so it does not exist. Next. Okay, let's go. Let me find somebody who didn't. So Parsa.
Is it a x approaching 2 from the negative side, left side?
What's with the questions, guys? What is it?
No, I can't properly see.
Oh, x approaches 2 from the left.
-1.
Perfect. Okay. Next, let me see. Faye.
Yeah, it would be 1.
2 from the right, it's 1. Perfect. All right, f of 2. So Alexandra, FV, I don't know what that is, Alexandra FV.
I think it's -1.
Good. You don't need to think, you need to be sure. It's right, it's -1. Okay, where the dot is. Okay, x approaches 4 from the left side. So I'm afraid to call on someone that is in high school. So I don't, whoever I'm not sure of the name, I'm not calling. So Monique, x approaches 4 from the left. Write it on chat. Nope. So you said it does not exist from the left. Okay, good. Infinity. Okay, if I approach 4 from the left, the function is going to plus infinity. Perfect. 5 from the left, 1 over f of x. Let's go back again. Ryan. No Ryan. Okay. Okay, so try. Okay, you don't know? You don't need to be sorry. Okay, so let's try. You don't have a microphone, Ryan?
I do.
Sorry? Okay, I can't hear. Okay, let's go. Vanisha.
I'm sorry, I'm just gonna like try to figure it out.
Okay.
It's like 1/0 infinity. So
Okay, but from the left, right? X approaches 5 from the left side.
okay, so that is 0.
Okay, that's 0, but if I'm approaching x 5 from the left, I'm approaching 0 from the bottom. Understand?
Yeah.
So this is like, you're right to say that it's 1 over 0, you're right, but it's 0 sort of with a minus.
Okay.
It's the negative side of the 0, so this will be minus infinity.
Okay.
Okay, good. Limit x approaches infinity f of 1 over x.
Sir,
Yeah.
I have a question.
Uh-huh.
If it was from the right side, it would be plus infinity?
Yeah, absolutely.
Okay.
Okay, limit x approaches infinity f of 1 over x. Irina?
Yeah, give me a second.
Okay.
Is it minus infinity or plus infinity?
It's plus infinity.
I don't know, to be honest.
Okay. You sure you don't want to try?
Well, I know if it's f of 0, but I don't know.
F of 0, perfect. So what's f of 0? What's f of 0? F of 0 is 1.
Oh, okay.
Okay, easy.
Yeah.
Okay with this? No questions?
Sir, can you re-explain this last one?
Of course. The last one here. This one here.
Yeah, just the one we did. Yeah.
So x is approaching infinity. That means that we have 1 over infinity inside. And so 1 over infinity is 0, and f of 0 is 1. No?
Okay. All right. Okay.
No problem. All right. Let's go with a few limits. Okay. So curve sketching, I guess we're going to do it next week. Okay. So we're going to start, I think, Monday. We'll do curve sketching, last section of the course, and then we'll come back to review. Okay. So let's continue today a bit more. So here goes. Let's do a few limits. So evaluate. So a limit as x approaches 3 to x squared minus 5x minus 3 over x2 minus 8x plus 15. Okay, should I do it right away or you want to try it?
Let us try.
Okay, so try it. Okay, try it, and in the meantime, I'm going to set you up with the second one. Okay, so of course you could do L'Hopital's rule. You're allowed to do whatever you want now. Limit, second one, theta approaches 0 of theta squared minus theta over the tangent of 4 theta.
In the second one, is it 4 times theta?
Yeah, it's 4 theta.
Thank you.
C. Okay, I hope I'm leaving enough space to answer it, but limit x approaches infinity, square root x2 plus 5x minus square root of x2 plus x plus 2x. Okay, so the first thing we do here, of course, we'll replace 3 inside. If you replace 3 on top, you get 0. And if you replace 3 on the bottom, you get 0 as well. And so what can we do? 2 options. Give me 2 options.
L'Hopital's rule.
L'Hopital's rule is perfect. Or you could, of course, factor the top, factor the bottom, and start crossing out south. Okay, but I think L'Hopital's rule is best. Limit x approaches 3, derive the top, you get 4x minus 5, and derivative of the bottom is 2x minus 8. Now you plug in 3, I get 12 minus 5 is 7. And on the bottom, if you plug in 3 inside, you get 6 minus 8, and it's negative 2. Right?
Yeah.
That's what you got?
Yeah.
Okay.
Yes.
I didn't get.
No, I don't know who said 2.
I don't know. I just.
Sorry?
Okay, never mind. I know my error.
Okay, I don't know why yeah, okay, whatever. Okay, let's do this. Next one. So you plug in 0 in here. again. So 0 minus 0 is 0, and the tangent of 0 is also 0. So we could do L'Hopital's rule again. So limit as theta approaches 0, derivative of the top is 2 theta minus 1. And on the bottom, I have this derivative of tangent is the secant squared of 4 theta. Is that okay?
Yeah.
Are you sure?
But don't you do chain rule?
So what am I missing?
4?
4.
Okay, times 4. Don't forget the 4 here. Okay, the chain rule, the derivative of 4 theta is 4. And now I replace the theta by 0. On top, I get minus 1. And on the bottom, the secant of 0 is 1 times 4 is 4. Okay, secant of 0 is 1 because secant is 1 over cos, and cos of 0 is 1. Good?
Yes.
Okay. What do I do here?
Sorry.
Yes,
Sorry,
yes.
Could you re-explain the secant times 4, like the chain rule?
Oh, the chain rule here?
Yeah, yeah. The why do we do times 4?
Because it's a function of a function.
Oh, okay, thank you.
Tangent of a function. Okay, so you derive tangent, you're right, secant squared, times the derivative of the inside, which is 4. All good?
Yeah, thank you.
Here,
So,
yes, yes.
why did you put minus 1 on the top? Isn't it supposed to be just 1? It's 2 minus 1.
No, theta is 0.
Oh, okay. Yeah.
2 times 0 minus 1, okay? Here, if x is infinity, so here I have infinity minus infinity, so there's no L'Hopital's rule here. What should I do? What do you suggest?
You can multiply by the conjugate.
Okay, so let's rationalize. Perfect. Limit x approaches infinity, square root x2 plus 5x minus square root x2 plus 2x. And this is, it's like over 1. And I will multiply by the conjugate. So let's multiply with the conjugate right here, which is the same thing, but with a plus in between. Okay, same thing, of course, on the bottom. Okay, equals. So limits x approaches infinity. So this is a difference. A minus b times a plus b is a2 minus b2. So I have x2 plus 5x minus b squared, which is x2 plus 2x. And on the bottom, I have this thing, square root of x2 plus 5x plus square root of x2 plus 2x. Okay, this could be simplified further. x2 minus x2 is out, 5x minus 2x is 3x. And on the bottom, I have x2 plus 5x in square root plus x2 plus 2x. Okay, now what?
Now you can factor out an x out of the root and you can cancel the x's.
Perfect. So now I have, well, if I plug in infinity here, I get infinity over infinity. So theoretically, I could even do L'Hopital's rule here if I wanted. Okay, it's just that nobody wants to derive a square root. It's annoying. So let's pull out, like you said, I think it's wiser to pull out an x from the denominator. 3x, and then on the bottom here, I pull out an x from everything. Okay, an absolute value of x, don't forget. And the first root will be 1 plus 5 over x, plus the second root will be 1 plus 2 over x. Okay? Now, since x is approaching positive infinity, so that's a positive number, so I don't care about the absolute value. And these two could just cross out. 5 divided by infinity is 0, it's out. 2 over infinity is 0, it's out. And so I have 3 over square root of 1 plus square root of 1, that's 2. And so my answer is 3 over 2.
But sir,
Yeah.
why isn't the infinity minus infinity like from the beginning just 0? Why can't we just say that it's 0 at the beginning?
Okay. Why can't we say that infinity minus infinity is 0? Let's see if I could prove that to you. So why isn't infinity minus infinity 0? That's your question?
Yeah. Yeah.
Okay. So let me see. Infinity plus 2 is what?
Infinity.
Good. So infinity plus 2 minus infinity will be, so infinity minus, so this will be 0? Or not?
No, I don't know.
I went too fast, 1 second. Okay, so infinity plus 2 is equal to infinity, you say? So I'm going to send this infinity on the right side. Okay? That's okay?
Yeah.
But you
No.
told me that infinity minus infinity is 0, so we just showed that 2 equals 0.
Okay.
So I
Yeah.
think you can do that, okay?
Yeah, thank you.
Sir, could you lower the page a little bit, please?
Lower, you want to see the top?
No, the bottom.
Oh, that's the lowest I could go.
Oh, okay, that's it. Okay, thank you.
That's just back here.
Sir? Sir,
Yep.
could you explain why did we pull out the X?
Why did we pull out the X here?
Yeah.
Because that was the, if you remember, the method to evaluate limits at infinity when you had square roots. Okay, you pull out the maximum exponent from the denominator, the top degree.
Oh, okay.
Remember?
Yeah.
Okay, let's go.
Why is it absolute value?
Sorry?
Why is it absolute value?
Because the square root of a number is always positive. So if what I did here, okay, what I did, let's say here, okay, square root of x2 plus 2x, it's equal to the square root of, so x2 times 1 plus 2 over x. I don't know if you could see, it's a bit small. And that's square root of x2 times square root of 1 plus 2 over x. Okay, that's what really I did. I just distributed the root on each. And the square root of x2, this is absolute value of x. Okay, it's not x. What?
Even if x is negative, it's still to the power of 2, so it's still going to be positive.
Yeah, but if you do square root, you can't, for example, you cannot do this. Let me show you. You can't go like this. That's cheating. If you go -3 power 2 square root, okay, and then you're going to cross this out and say that it's equal to -3. You can't do that. You understand? Because or else you're going to allow me to do this. Right? That's square root of 9, and that's 3. And then on the other side, you're going to do that's -3 power 2 power a half. That's -3 power 1, and that's -3. And there in 2 seconds, I show you that 3 is -3. Okay, you can't do that. Okay, it's like this. It's like if I do this, square root of 1, that's equal to 1. That's equal to the square root of -1 times -1. That's true. That's equal to square root of -1 squared, and that's equal, right? Same thing. And so it's like x squared root, and you say just x, so it's -1. So you can't. Okay, so that doesn't work. So the rule for this is that the square root of x2 is always equal to absolute value of x. Okay, the square root is a positively defined function.
Thank you.
Okay, no problem.
So does it mean that every time there's a variable under square root, it has to be positive, no exceptions?
It has, what do you mean? A variable on its own, square root of x? Or everything that's inside?
No, I mean the value the variable is going to take has to be always positive.
The whole thing, everything
That-
that's inside the root has to be positive, for sure. Right? Or else here, if x2 plus 2x gives you a negative number, for example, if x is -1 here, that doesn't work. Okay? If x is -1, you get 1 minus 2 is -1, can't be. So right away here, like you would do in high school, you would put some restrictions here. X is at least whatever. You understand? So that's, there's a domain of this function. But for now, that the question that's been asked is, why is this absolute value? Because, like what I just said, square root of anything is always a positive number. Okay, it's good. You're asking good questions that you weren't asking at the beginning of the course. So it means that you're starting to get more comfortable. Okay, D. D, C, which is a C. So if, here's a question, if f of x satisfies the following thing. So f of x is between x2 minus 4 over x plus 2 and x2 plus 5x plus 2. Okay, so if f is stuck between these two functions, find the limit as x approaches 2 of f of x. Sorry, minus 2. X approaches minus 2. Okay, that's a minus here. And E, I'm going to set you up with E. In the meantime, limit as x approaches 4 from the left, absolute value of x minus 4 over x minus 4 squared. Okay, go for it. Take a few minutes, try it out. So how do we do the first one? Any idea?
You can take the limit on both sides.
On all three sides. So this is, what is it called? What's this called?
Squeeze theorem.
Very nice.
Squeeze.
So, perfectly. So since f is squeezed between two functions, so basically it's something like this. I'm going to try to represent. Okay, so at minus 2, that's where I'm interested in. And so there's a function here, another function here, okay? And then there's f that's between both of them, okay? So limit as x approaches -2 of x2 minus 4 over x plus 2, it's definitely smaller than limit x approaches -2 f of x, which is smaller or equal than limit as x approaches -2 of x2 plus 5x plus 2. So this is very simple. If you do L'Hopital's rule, or if you just factor, you're going to get -4, right? -4 less than or equal to the limit as x approaches -2 of f of x, less than or equal. If you plug in -2 here, you get -10, -8 minus plus 4 is -4 as well. And so this limit is squeezed between -4 and 4. So the limit as x approaches -2 of f of x is equal to -4. And this is thanks to the squeeze theorem. Okay. Yes.
Sir,
Yes.
is it okay? Like I didn't use squeeze theorem. I just did it like from the left and from the right.
What do you mean from the left?
I
What-
don't know. I don't know. I just thought the one on the left is like from the left. 'Cause it's
No.
smaller. No. Okay.
You have no choice. You have to do the squeeze theorem here.
Okay.
Okay.
Thank you.
Okay, the second one here. So x approaches 4 from the left. Limit x approaches 4 from the left of. So if x is 4 from the left, means that x is a bit less than 4, which means that x minus 4 is a negative number. And so I could get rid of the absolute value by putting a negative in front. Okay, we did a few of these, I remember. So do you understand this?
Yeah.
Okay, anybody, questions?
Yeah.
Yeah, means you understand or you have a question?
No, we understand.
Okay, perfect. And then that's it. I'm just gonna cross out one of the x minus 4s. And so I'm left with x approaches 4 from the left of -1 over x minus 4. And that is -1 over 0. Is this going to be infinity, minus infinity? What does not exist? What is it going to be?
It's going to be positive infinity.
Positive infinity, perfect. Because again, x is approaching 4 from the left, means that's x minus 4 is a negative number, and so negative over negative is definitely positive, and so we get positive infinity. Okay. This is for the limits. Okay. We have time for one more. Do we have time for one more? Let's do one more. Okay. So limit as x approaches 5 of x squared minus 3x plus k over x2 minus 4x minus 5. Okay, the question is A, find the value of k to make the limit exist. And be finite. Okay, finite means a number. And B, what is the value of the limit in that case? Okay, any idea?
-10.
-10 you got?
We do from left and right.
I don't think so.
I just said that like if we want to use the L'Hopital's rule, the top and the bottom has to be equal to 0. So I just found that value that makes it equal to 0.
Okay, so the fact, the idea is the fact that the bottom, if I plug in 5 inside, is already 0. Okay, so let's do A, because we're running out of time. So limit x approaches 5 of x2 minus 3x plus k over x2 minus 4x minus 5. Okay, so this is, if you plug in 5 inside, you get 25 minus 15 is 10 plus k over 0. Right? So like you said, the only way that I could have a limit is if k is minus 10. If k is anything other than minus 10, I will have a number over 0, and that can't be. You'll have infinity or minus infinity. You understand? So we must have 10 plus k equals 0, which means that k is equal to negative 10. Okay, and then B, what is the limit in that case? x2 minus 3x minus 10 over x2 minus 4x minus 5. So now it's a regular limit. Plug in 5 on top, 5 on bottom, you get 0 with 0. And now either you factor or you do L'Hopital's rule, whatever you prefer. Okay, and in both cases you will get what? I'll do it. I'll do L'Hopital's rule. Limit x approaches 5 of 2x minus 3 over 2x minus 4. So 10 minus 3 over 10 minus 4 is 7 over 6. Oops, I can, sorry, you can't see the bottom, I just realized.